The last video was about vertex form. This video is about standard form. Standard form is the form we're more accustomed to seeing quadratics in. Y equals ax squared plus bx plus c. The vertex is not obvious in standard form, unlike vertex form where we can read it right off. And as a quick review, the vertex in standard form is just the point h comma k. In both of these forms, a controls the speed of the growth. So if a is large, in either of these forms, the parabola is going to be narrower, it's going to grow faster. If a is small, less than 1, the parabola is going to grow slower and appear wider. If a is negative, the parabola is going to open downwards instead of upwards. In standard form, it's straightforward to apply something called the quadratic formula, which we'll get to soon. But in vertex form, you need to move some things around before finding the zeros using the quadratic formula. Standard form is also, it's more involved to find the zeros using completing the square. Vertex form is actually very easy. And lastly, standard form appeals to our sense of order, whereas vertex form looks really funky until we get used to it. So standard form, finding the vertex is the key to graphing parabolas, and in standard form we cannot read the vertex right off. And I wish through these videos I could develop for you why the x-coordinate of the vertex is at negative b over 2a, but instead I'm just going to jump to it. This negative b over 2a should actually look familiar if you know what the quadratic formula is. So the quadratic formula is a way to solve quadratics, to find the zeros or the x-intercepts of quadratics, and it's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This is actually going to be a topic that's coming up soon, but not yet. So where this negative b over 2a comes from, we can actually think of it as being the very first part of the quadratic formula. So that negative b over 2a, that's the x-coordinate of your vertex. How to find the y-coordinate is you just take whatever that number is and plug it into the equation. So let's find the vertex of y equals x squared plus 2x plus 2. The a and b come from the coefficients in standard form. Since standard form is y equals ax squared plus bx plus c, we're working with those a's and b's to find the vertex. In this case, a equals 1, b equals 2, and c also equals 2. So negative b over 2a becomes negative 2 over 2 times 1, which simplifies out to negative 1. So that's the x-coordinate of our vertex. To find the y-coordinate, what we're going to do is we're going to plug in negative 1 for x. Y equals negative 1 squared plus 2 times negative 1 plus 2. Negative 1 squared is positive 1, minus 2 plus 2 equals positive 1. So our vertex is at negative 1 comma 1. If we wanted to graph this, what we would do is we would make an xy table and we would start at the negative 1 comma 1, and then we'd either use the pattern where we go up 1 over 1, up 3 over 1, up 5 over 1, because our a term is 1, or you could just plug in the next couple of numbers and solve for y for each one of those and just plot those points. So let's graph this, but before we get there, I want to answer some questions. Does this parabola open upwards or downwards? To answer that, we look to the a value. That a value is 1/3. Since it's positive, that means this parabola is opening upwards. Does the parabola grow slowly or quickly? Well, since 1/3 is smaller than 1, that means it grows slower than our parent function of y equals x squared. Finally, let's find the vertex. So for the vertex, I know the x-coordinate is going to be negative b over 2a, and then I'm going to write the y-coordinate as f of negative b over 2a. I know we're working with an y instead of an f of x, But we could think of that as an f of x equals 1/3 x squared minus 4x plus 14. And so what this f of negative b over 2a, if you recall function notation, if we find a value for x, we can just plug that in to find the y. That's what this function notation is saying. Plug in the value to find the y. Okay, so a is 1/3, b is negative 4, negative b over 2a equals negative 4 over 2 times 1/3. That's 4 divided by 2/3. Dividing by a fraction is the same as multiplying by the reciprocal, so this is 4 over 1 times 3 over 2, which simplifies out to 6. So there's the x-coordinate of our vertex. Now we need to find the y-coordinate. To do that, the y-coordinate is going to be this function evaluated at x equals 6. I think of that as f of 6 equals 1/3 times 6 squared minus 4 times 6 plus 14. 6 squared is 36. 1/3 of 36 is 12 minus 24 plus 14. That adds together to be 2, if my mental math is correct. So our vertex is 6, 2. So I'm going over 6 and up 2. I know my parabola opens upwards, so I could use the 1, 3, 5 pattern, but it's going to be multiplied by 1/3 each time. Instead, let me just build a table. I'm going to start at 6, 2 because that's my vertex, and I'm going to plug in 3 for x. I don't want to do 5 and 4 because I'm going to end up with fractions, and I don't particularly want to graph fractions. So I want to choose something for my x that's divisible by 3. So that means my next number is going to be a 0. That should be enough to get us the graph. So when x is 3, f of 3 equals 1/3 of 3 squared minus 4 times 3 plus 14. That's 1/3 of 9, which is 3, minus 12 plus 14, which means that works out to be 5. When x is 0, 1/3 of 0 squared is 0, minus 4 times 0 is 0, plus 14. Plotting these points, I think I overshot with our 0 because that point is like up there. But we can see roughly what this equation is going to look like. It's like that. All right, some other quick things about the vertex. The line of symmetry is the x-coordinate of the vertex. And by line of symmetry, to go back to this example we just did, the line of symmetry is where we could fold that in half and it would be symmetric. So as you can see, it goes right through the vertex. And so the line of symmetry in this problem is x equals 6. Because x equals, that gives us our vertical line. The minimum or maximum value is the height or the depth that a parabola reaches. And this peak or valley is always at the vertex. In fact, this height or depth, if we think about up and down, the y-coordinate has to do with the height or depth. And so the height or depth is always the y-coordinate of the vertex. For in class, we actually have this example problem. For you online, you can go ahead and work through this if you wish. Thank you.